Yes, I'll do any that y'all want to see. Okay, so 5C, let's look at that one. Okay, so this fits, you know how I gave you guys a list over there? This one fits with the empirical rule. Okay, and basically for the empirical rule, you want to be able to memorize the little curve that we learned. Okay, you have to memorize this because it's not going to be given to you. So let's just kind of walk through that. So 68% is in the middle. That means that's within 1 standard deviation above or below. So that means this is 0.34, this is 0.34. Okay, that's your 68%. Then within 2 standard deviations above and below, you have what? Do you remember?
13.5.
Yeah, it will be 0.135 or 13.5%, because from 2 above to 2 below, you should contain 95% of the data. Okay, so the rule is called 68, 95, 99.7%, or the empirical rule. So those are the ones you need to memorize, as well as these little slices here. Then within 3 standard deviations above and below, you'll have what? Do you remember how to find it? If you forget, you have to take the 0.997 minus 0.95, and it gives you the tail. 0.997 minus 0.95, and that leaves you with 0.047 divided by 2. So 0.0235, which is I think what somebody said. Jack, was that you? And then 0.0235. And then you have in this little bitty tail 0.0015. Now that you just have to memorize. And it's nice and neat on a handout that I gave you last week. Okay, so it was C that y'all needed to see here. Spend more than $73. So I'm going to have to kind of fill in this. And for the empirical rule, you want to fill in your horizontal axis there. The mean is 55, and I'm literally just going to add 18. Okay, tell me how good. Okay, and then you want to go, one more. So you want to go 3. Does that make sense? So this is going to be what over here? Okay, very good. Now, so these little slices are what I was talking about up here. So what percent of the people spends more than $73? So 73 is right here. So basically it's going to be these 3 slices. So this is a good way to think about it. 73 is what? 1 standard deviation above the mean, which is right here. This is 1, this is 2, and this is 3. So it's going to be this slice, and that slice. So it's going to be 0.135 plus 0.0235 plus 0.0015, and that should give you 16%. Now this is saying what percentage, so you just have to make sure you're answering the question. If it said what probability, I just do 0.16, so that's the only difference. Okay, so how is that for the empirical rule? It's because the mean is right here in the middle. If I go 1 standard deviation below or 1 above, this whole area is going to be 68%. It's because of the symmetry. These are equal, so just divide by 2. This one, though, is a little bit harder. What you have to do is you have to say, okay, if 68's here, and then 95 is all of this, just do 95 minus 68, and that gives you this area, but divide by 2 due to the symmetry, and it'll give you those little slices. Plus, could you just memorize those? Practice writing it out and filling in those slices. How many do you need? You need 4 on each side, but they're the same. So just 4 little numbers you've got to remember. 0.34, 0.135, 0.0235, and 0.0015. Okay, so any others from 5 that you'll need to see? Okay, so jump down to number 7. Okay, 7 is almost like a conceptual problem. it wants you to understand that just because someone has a higher salary doesn't mean they make more money relative to their population. So let's just do A. Mr. and Mrs. Newton are married. Mr. Newton works at Harrison. Okay, so he works up here. And Mrs. Newton works at Center Valley. So this will be Mrs. Newton. This is how much Mr. Mr. Newton makes. This is how much Miss Newton makes. Just be careful with that. Who is higher paid within their district? So what I have to do is I have to compare their salaries to the district. So let me do the Z-score for Mr. Newton. And remember, the formula is going to be your observed value, like your observed salary, minus the mean over the standard deviation. So Mr. Newton makes $57,000, and in Harrison, most people make what? $51,033, and then divide that by the standard deviation. Okay? So what do you get when you do that? Y'all practice this because this is going to be on the test, obviously. Did y'all get 0.69? Did anybody get 0.69?
Yeah. Well, I should have done 0.695.
0.695?
Because I used 0.6895.
Okay. And yeah, and if you're using the table, you do want to round to the hundreds because that's where the table gives you. But in this sense, we're not even using the table for this problem. So you'll understand why in just a minute. So let's do the Z-score for Mrs. Newton. And Mrs. Newton makes $58,250. So it seems like she makes more money. And in Center Valley, 52,176, 9299. So do that in your calculator. And that gives us 0.65.
Yep.
Okay, so here's the question. If you draw your little curve, you have 0.65 and 0.69. So now you can actually compare them. Who makes more money? Mr. Newton, because he makes, relative to his district, he is higher paid, but his district just doesn't pay as well. So it could be that he has more seniority, even though he is not making as much money, he is higher paid relative to his peers. So again, this is a little bit harder to understand, but remember when we did like the ACT and SAT example, where you can actually then compare two very different scores or scales, like ACT and SAT are scaled very differently. But that's how you would do that one. And who asked for that one? Does that make sense?
Yes.
That's all I'm really doing. Now down here it gets a little bit tricky because you end up with negative. So let's talk about that. And where did the key go? Well, we'll just do the Z's down here. Okay, so we have Mr. and Mrs. Sun. Mr. Sun also works in Harrison. So his Z is going to be 47,000 minus, again, he works in Harrison. Okay, so you need to do that one, and then let's do the same thing for Mrs. She makes 48,000. And again, 52,176 is the mean. Okay, so y'all tell me what you get for those. Did you get negative 0.47?
Yeah.
Okay. And then for the other one? Negative 0.45. Now, when you put these on the curve to think about them, be careful. Negative 0.45 is bigger than negative 0.47. I'll put that right there, okay? So negative 0.45 is actually scoring higher. So Mrs. makes more here, Mr. made more here. So higher paid, okay? So just be careful with the negatives. Now, why are these negatives and these up here were positive z's?
They got paid like the above average.
These get paid above average, these get paid below average. Very good. So that's the only thing. You didn't even need the table for this one. You're just comparing your z-scores and seeing which one's bigger. Bigger is better in this case. Bigger is not always better, okay? In terms of like the cars that we compare on number 8, because some of y'all said you had a question about number 8. So let's look at number 8. Here we're talking about the age of cars. Well, the older is not better, right? Newer is better with cars, typically speaking. Typically speaking. You could have some classic car that's worth a ton of money that's old, but typically speaking. Okay, so how would we do this problem? Well, do you see that it doesn't say empirical rule here? If it doesn't say empirical rule, then don't waste your time filling out one of the curves and doing like the mean, 1, 2, and 3 above, 1, 2, and 3 below, because you're just wasting your time, because you're not going to be able to use it. These don't fall right 1, 2, or 3 above, or 1, 2, or 3 below. So we're going to have to actually compute the z-scores. So remember our z-score formula, it will be given to you, but it's observed minus the mean divided by the standard deviation. So that's what I'm using here. So the z-score here is going to be 5 minus the mean of 4.65 divided by 1.24. And what does that give us? And practice this with me. And what'd you get? 0.2823, but you only need 2 decimal places because that's as far as the table goes anyway. So just do 0.28. Now, when I look up 0.28, let's think about where 0.28 is. Well, we know 5 is a little bit to the right, so 0.28 is a little bit to the right of the center. Okay? Now, the table is going to give me this area. So let's look that up. So I'm going to my table and I'm looking at 0.28. Because it's a positive z, I just use this half of the table. So, okay, very good. 0.6103. Does everybody see that? Let me zoom in. 0.6103 is right there. 0.28. So this is the tenths, that's the hundredths, and that's the area to the left, 0.6103. So this is 0.6103, right there. Now, what did this question ask me? Older than 5 years. So wasn't I really wanting these old cars over here? So I'm going to have to do 1 minus 0.6103. And what's that going to give me? 3897. Okay? So that's because we needed the area to the right. We needed the older probabilities, or probability for older than 5. But the table always gives us the area to the left, so then we subtract. So that's one of our scenarios. Let's do B. Newer than 2 years. Well, 2 years is going to be over here somewhere. And we want newer. Are these our newer ones, or these are newer ones? Like left or right? Left. Okay. So we want this area. So we need the z that goes with 2. So that's going to be 2 minus 4.65 divided by 1.24. And what do you get there? Negative 2.14. Now let's look that up on the table. You know it's going to be in the left half of the table. Negative 2.14, 0.0162.
Yeah.
Okay, did everybody get that? 0.0162. And that is the area to the left. So we're done. We don't have to subtract. So when you need the area to the right, you're going to have to use the table and subtract from 1. When you want the area to the left, you just look up the area in the table and you're done. Does that make sense? Okay, what about between? Like, what about D? That's when you have 3 and you have 6, and you want between. The table does not give us between. It gives us area to the left of 6. Well, we're going to convert it to a Z, of course, and the area to the left of 3. So this is when you always do larger area minus smaller area. So let's think of the smaller area like as this polka dotted region. So when I look at the z for 6, it's going to give me all the area. Look up the z for 3, and it gives me the polka dotted. So if I take the larger minus the smaller, it will give me the in-between area. So we need our z for 6, and we need our z for 3. So 6 minus 4.65 divided by 1.24. What do you get for the z of 6? It's positive. 1.09. Okay. What about the z of 3? Negative 1.33. We're going to look both of those up in our table. So 1.09. And guys, before I move on, it's not that this one's positive and this one's negative. They happen to be, they could both be positive, they could both be negative to get an area between. You always just look them both up and take the larger area minus the smaller area. 1.09 is going to be what? 0.8621?
Another one is
0.0918. 0.0918, and we subtract, and what do you get? 0.7703. Is that right? And it asks for what? The percentage. So it's going to be is that what we're talking about? And then, so it's going to be approximately 77%. Okay, and these should have been in percents too. I messed up on that. So this would be 1.62%. This would be 38.97%. Okay, so that's kind of how you do that topic. When you're given values and you convert them to z's and use the table. So that's kind of like the third bullet down. Okay, in my little recap of everything. So let's summarize this. If you need the area to the left, you just use the table. You find your z, you use the table. If you need the area to the right, and I'm just going to draw, this z could be anywhere, guys. You use 1 minus what you find in the table. Does that make sense? So 1 minus what you find in the table. Area between is going to be larger area minus the smaller area. E from, okay, the 85th percentile is when you have 0.85 to the left. So what you're going to do is is that the one you're talking about? Yes. You're going to look up your z, but this is different because it's like working backwards. So you're going to go to the table and look for 0.85 and go as close as you can find. So it's between these two. This one's a little bit closer. Y'all see there's 0.85. Let me zoom in a little bit. Okay, and then what I do is I go over and up. So the closest z is 1.04. Y'all with me? 1.04. Okay, so the z is 1.04. And remember there's a formula that x is going to be what? Mean plus what? Z standard deviations, right? This was the little extra formula we put on one of your little sheets. Oh, I'm sorry. Okay. So it's just going to be the mean, which was 4.65, plus 1.04 standard deviations of 1.24. Okay, and what does that give us?
I did that wrong. Why did you use that one?
I'll show you in just a second. 1 point, wait.
You have 5.93.
5 point, what did you say?
5.9396.
5.939, so we'll just do 5.94 years. Okay, now where did this formula come from? It came from this formula up here. So y'all think through this with me. If you're solving for this x, when you multiply both sides by standard deviation and then add the mean, So that's where this is coming from. It's the mean plus z standard deviation. And honestly, I cannot remember if that formula is on the test. If it's not, I'll write it down for you. So don't worry about that. Okay, I'll just give that formula to you. Most of the formulas are on the test. Now we need to do a confidence interval one. Y'all pick one out. They're kind of on the back. Number 9. Well, number 9 is kind of like number 8. So, yeah, we will come back if we have time. Okay, but we'll come back if we have time. So 13, y'all say? Okay, 13 is down here. We'll just do this one real quick because it's not. This is just kind of setting it up for doing confidence intervals. Give the formula for constructing a confidence interval about the mean. You take your x bar, you add, this is just your mean. You add and subtract your critical z, and I'll talk about how to find that in a minute, standard deviation divided by square root of n. So this is standard deviation, and this is just your sample size. Okay? Kind of ran off there. Okay, what part of the formula is considered the margin of error? Well, it's all of this. So I'll just say margin of error is boxed in. So you need to add and subtract the margin of error. Margin of error. Why does the formula divide by the standard deviation or divide standard deviation by square root of n? Because you're dealing with samples. And samples are not as spread out. We talked about that in class, but you're dealing with samples. They're not as spread out as individual observations. So that's really all you need to know. This one right here is the biggie. If you forget how to find your z-star, you're going to kind of be in trouble. So let's do a couple of these. So 80% is in the center. And the little formula says use 1 minus 0.80 divided by 2, and that's going to give us 10% in each of these little tails. Okay? So I have to look up 0.10 as an area in the table. And when I say that, these are my areas. Here, guys, these are my z's. So I'm going to look up 0.10, go as close as I can get. That's actually a little bit closer, isn't it? Negative 2.33. Negative 2.33. So that would be the z here. Now, remember, this one is a positive 2.33. This is a negative 2.33. Okay? So that's for an 80% confidence interval. What about a 90%? For 90%, I would do 1 minus 0.90 divided by 2, and that's going to give me 0.05 in each of these little tails. So now I go to my little z table, and I'll look up 0.05. In the body, 0.05. So it's halfway between these two, negative 1.6. So in this case, I might even just split the difference. I would not count it off if you did negative 1.64 or negative 1.65. But it's halfway between. So let's do 1.645. So this would be a negative 1.645. This is 1.645. Now, why do I need that? Because I'm going to use it right there in the formula. And that's it. Okay? So let's look at number 14 because this asks us to do this. So the manager wants to estimate the average amount a customer spends on lunch, and he asks 115 customers. That's his N. That's the sample size. His mean is 9.74, and the standard deviation is 2.93. So 95%, we need our Z that goes with that. And this is the most common confidence interval. It's negative 1.96 and a positive 1.96. You want me to show you how to get it, though? So 0.025 is in each tail. So you'd look that up, and you would get that negative right there. So I'm going to take my mean of 9.74. I'm going to add and subtract 1.96. The standard deviation is 2.93, and divide by the square root of 115. Now I'm going to show you how I'd suggest to do this. Remember, this is x bar plus and minus your critical or z star, like that. So I'm just going to add it to start off with, and I'll show you how to do the other half of it. 9.74 plus 1.96, and then I'm going to do 2.93 divided by the square root of 115. Now make sure to close the parentheses the right place. Now this is going to give me the higher amount, 10.28. 10.28. Now all I have to do is do second and recall, second enter, and then I go over, and guess what I'm going to change? I'm going to change it to subtract, because I need to do a plus and a minus. Did I go too fast?
Yeah.
Okay, I'll show you again. So that's the lower part, 9.20. What? It does save a lot of time. And that way you don't make mistakes with it, okay? So all I did was I did the plus first, and then I did second recall. Always pulls back the last thing you entered. Whereas second answer, which is this little button here, pulls back the actual last answer. You're not doing that. You're doing a recall of your last keystrokes. Okay? Now, how do we interpret this? We are, every time, the same way. 95% confident. Where am I getting that from? Because we were told to do 95%. We are 95% confident that the true mean lunch amount, tab, we'll say lunch tab, is between $9.20 and $10.28. So we're 95% confident that the true mean lunch tab is between $9.20 and $10.28. Technically, it's Monday through Friday, because it might be different on Saturdays or Sundays. Maybe it's higher on Saturdays or Sundays. I don't know. That kind of thing. How about number 16? I'll set it up really quick. So we want our standard deviation to be plus and minus 10. So guys, this is going to be our margin of error. Okay? So remember, our margin of error is z star standard deviation divided by square root of n. Well, we're trying to find n. And we know our z from a 95% is plus and minus 1.96. So I'm going to say 1.96. The standard deviation is 44 divided by square root of n, and that has to be equal to 10. Okay, y'all might see something like this tomorrow. It'd just be one problem. I would probably multiply both sides by square root of n, so that will go away, and then I can divide by 10. Divide by 10. So I'm down to this. If I square this and square that, I will get in. So it's going to be 1.96 times 44 divided by 10, all squared. So let's look and see what that looks like in the calculator. 1.96 times 44, get that value, divide by 10, and square it. And you always round up, so I'm going to say 75 saplings. I don't know if y'all can even see that. So n is going to be 75 saplings. That is correct, guys. Okay, y'all study hard, and